Hello, and welcome to Electric Field Hockey. If you couldn't get the Java version of this running on your computer, you can follow along with this screencast and hopefully get the answers you need to complete the worksheet. So feel free to pause at any time and write in your answers. So the goal here is to manipulate this positive test charge, which we're calling the hockey puck, into this blue bracket over here, which is the goal box on the right-hand side. And the way you move this test charge is by placing negative and positive charges to create an electric field which will guide the puck into the goal box. Okay, so the first thing we're going to do is place a negative charge, one of these blue charges up here, behind, just to the right of the goal box. Okay, and then I'm going to come down here and press start and see what happens. And we see that very slowly the puck starts moving. Oh, yay, we made it. So that negative charge pulled on the top positive test charge and brought it straight towards it into the goal box. Note not only the direction that it moved, but the speed and how the speed changed as it got closer to the negative test charge. And for the second part of question number 1, does the negative charge attract or repel the positive puck? Remember, attract means pull it towards, repel means to push away. Okay, moving on. It says to hit the clear and reset buttons. We're going to reset everything. And try to place a single positive charge so that it drives the puck into the goal. So this is where you would have the choice of where you want to put the charge, but you'll have to just trust me to do that. And you can see that depending on where I position the test charge, whether it's near or far away, it will have a different effect, and the location will also direct what direction it moves. So a longer arrow in this case will represent a stronger force, and I want it to go into the goal box. Okay, so this is going to work by repulsion. That positive test charge is going to repel the positive puck. Right? And you can try and predict, even before you see it, what direction and speed the puck is going to move. I'll go ahead and hit start and we can see what happens. All right, so in this case, did the positive charge attract or repel the positive puck? Go ahead and write your answer down there. I'm again going to clear and reset the field. This time I'm going to turn on these little features down here. Trace, where it's going to trace the path that the puck goes along, and field, where it's going to show the field lines once we place a charge. And we're also going to do this, anti-alias. Okay, now place both positive and negative charges and run the simulation again. So basically I'm going to do the same thing, but this time you'll be able to see the fields around each of these charges. And I'll press start. Okay, no surprise, it made it into the goal. We're still kind of in practice mode, but hopefully you're getting an idea of how these electric fields around each charge work. So when it asks what direction do electric field vectors point for the positive charge, the vectors are these little black arrows. And they point in different directions, but we're talking about in relation to the puck. Nope, that's not right. Sorry, we're talking about what direction they point for the positive versus the negative. You see how for the positive, all the arrows point outward because they will repulse a positive test charge, and for the blue test charge, they all point inward because they will attract a positive test charge. And the next question is, how did the electric field vectors change as you added charges? Again, this would depend on what you choose to add. What charges you choose to add to the field, but in this case, if we add a few more, you can see each time you add a charge, it's going to, those field lines are going to interact and produce different patterns. Okay, last question. What would happen on this page anyways? What would happen if you changed the charge of the puck from positive to negative? Okay, what if we change this test charge here from positive to negative? Think about it for a minute and then I'll actually do it on the screen. How would it affect the field lines? Okay, we're going to change it now to negative. Okay, do you see how they changed? The field lines actually stayed the same, but the way they interact with the puck is going to be just the opposite. A negative test charge is going to repel a negative puck. Positive test charge will attract. Okay, so we're going to change the puck back to positive. Actually, we're going to clear and reset everything. Clear and reset. Well, we're still in practice mode. We're going to turn off trace field and anti-alias and place a positive charge directly left of the puck. Okay, positive charge is going to go right here. And then a negative charge. Nope. Sorry, we're supposed to turn this off. Negative charge is going to go right down here. And I'm going to place it so that the magnitude of the vectors, the strength of the field from each of these charges is about the same. Maybe I have to go a little bit far away for this one. Because the farther away it is, the weaker the pull or the push will be. Okay. Now, in what direction do you think the puck will start moving and why? Remember that each of these is going to apply a force on our test charge here, the puck, but they aren't going to have an effect that's separate from each other. These two forces will combine. And so my guess would be that it would go kind of right in between in this direction. Okay, and my reasoning would be that these two forces are going to combine to make one force in this direction that's stronger than either of these two individually. All right, so let's press start and see what happens. And oh, isn't that interesting? It didn't just go straight off in a line. In fact, it's still moving. Oh, is it going to make it into the goal? Oh, not quite. Okay, that was kind of cool though. Do you see what happened? As the puck started to move in the direction that we expected it to, it actually moved closer to this negative charge down here, and so a stronger pull then was affected on it by this charge. It ended up looping around and going all over the place. Okay, we're going to reset, but not clear. And now we're going to turn on trace, field, and anti-alias, which just makes the field vectors easier to see. And let's run it again, this time watching how it moves along those field lines. Okay. you can see it went pretty close along those field lines, following them until it got into a position where the momentum was forced backwards because of all of these vectors that are pushing on it. Okay. Right, as the puck moves under the influence of the repulsive and attractive forces of the other two charges, does it always move in the direction of the electric field? Small black and white arrows. Or was there ever a time where it actually moved in opposition to the direction that the field lines were moving because of the momentum? And then try and explain why that happened or why it didn't happen. Then think through how the distance between the puck and the charged particles affected the motion of the puck. So how did the motion of the puck change as it came closer to this negative blue and then closer to the positive red as it swooped around here? How did its motion change? Okay, we're going to reset and move to difficulty 1. I think I need to clear the field here. And we're going to place different charges until we make a goal. Now the goal is to try and make this in as few as possible, using as few as possible test charges. So let's see if we can do it with just 2. Let's see if I get it going down here and then it comes up here. It might not quite be enough. Maybe that will. Let's start. Let's see what happens. Not quite. Okay, let's move it up a little bit. Try it again. Well, it's going a little bit too far down, so let's move this a little farther away. See what that does. Closer. I want a little stronger, so I'll move that closer. Maybe move this slightly to the left. Oh, now I went too far. Okay, so maybe I'll go out this way. Oh, very close. Move it back just a little. All right, we did it. Now take a minute and draw where the puck started originally, where our barrier is here, where we place the positive and the negative test charge, and where the goal is. And then also draw the path that the puck took. Okay, now unfortunately, if you can't get this working on your computer, then you can't go on and try difficulty number 2 and 3, but I'll show you what they look like. Clear the field here. Here's difficulty number 2, where you have 2 barriers and you have to try and navigate through this way or around this way. Difficulty number 3, super challenging. You have to get it all the way through this path, just using different charges to guide the puck along the way. And I can't run into any of the barriers. So I hope you had fun with this activity. If possibly you could go to the library or go to a friend's house and find a computer to get this working on, or download Java and get it working on your device, then that would be great and you could have fun with it on your own. If not, hopefully you got the answers enough to fill out your worksheet.